Hi everyone, in this video I'm trying to demonstrate how to use a software called SAP2000 to analyze and design a plane frame. So before we look at the software, let's first take a look at the plane frame that we're going to analyze. So it's actually a very simple frame with two stories, okay, and beam A and beam B you can see, and then you have four columns, or two columns on each side. The distance between the columns is 10 meters, and the height of each floor is 6 meters, right? And this piece of paper is actually already uploaded to Canvas. And then all the material parameters, including the self-weight of material, that's the density, and also the Young's modulus, are given. The beam and column sizes are also given on the sheet, and then the live load and the wind load are also given there. And if you look at the frame, the live load actually consists of a point load acting on the second floor beam and a UDL on the first floor beam. And in the wind load, there are 2 point loads, one acting at point 81 here, and then another one at point 82 here. Okay, and then so make sure you download and print this out when you are reading or watching this video. So let's now start the open up the SAP2000. So the first thing that you should pay attention to is the unit at the bottom right corner. So make sure that you select kilonewton and meter. That's the unit we're working with. And then we try to build a new model. So on the top, find the file button and then the new model. So once you click new model, you can find this box in front of you, and on the first line we have a few buttons, and then on the right you can see this 2D frame. That's what we are trying to use. So when you click on it, so there are a few numbers that you need to input. First of all, is the number of stories, so 2 is correct. Number of bays, so a bay means if you look at this diagram here, if you got 3 column lines, that means you got 2 bays. So 1 bay is defined as the space between 2 columns. Okay, so here we only have 1 bay, and then the story height is 6 meters as given on the sheet, and then the bay width, that means the distance between the 2 columns, is 10 meters. And then once you finish these numbers, try to check the grid lines. So the program will create a grid line system. So we try to edit the grid or check the grid lines. So X grid means the horizontal direction. So in the horizontal direction, there are 2 grid lines, right? One for each column. For the left column, grid line A is at -5 meters. At B grid line, that's 5 meters. So total, that's 10 meters, right? The distance between A and B. But I prefer to change A to 0, to start from 0, and then B is at 10 meters, right? And then for the Z is talking about the vertical direction. So the first grid line is at the ground floor at 0, that's fine. Z2, that's the first floor, it's 6 meters from the ground floor, that's okay. Z3 is 12 meters from the ground floor, that's also okay. So once you check these numbers are okay, you click OK. Right, so this is done. So in front of you there are 2 windows, and usually I would try to work with the XZ plane. So I click the left window, and on the top, this XZ button, I click this. Okay, so now you have 2 exactly the same windows. Now what we're going to define is, first of all, the material. So you first define the materials. So there are two material names. So we try to modify the first one. So instead of using this funny number, I try to change this name to, let's say we're going to use grade 40 concrete. So I just say the name is grade 40. And then the material type, of course, is concrete. This is a concrete frame. The density of material as given on the sheet is 24. And then the Young's modulus, that's the modulus of elasticity, it's 2.6 times 10 to the power 7. So I will change this to 2.76, so 26 with 1, 2, 3, 4, 5, 6 zeros. Okay. So once this is done, it's done, right? The other numbers are not important to us. Right, so this is done. And then the second thing is to define the cross section. So you go to section properties, define section properties, frame sections. So frame refers to beam or column. So we try to add new property. So the first one, so try to choose concrete rectangular cross section. So the first one we're going to define is the beam A, the first floor beam. And as given on the sheet, the width is 800 millimeters, so this is 0.8 meters. And the depth is 1.2 meters. Okay, make sure that the material is grade 40. And then if you click the concrete reinforcement, try to check this button because they will be designed as a beam in part 2. So click beam. Okay, so when this is done, beam A cross section is done. Now add another one for beam B. So beam B, that's for the second floor. The width is as given 0.6 meters wide and then 0.8 meters deep. Right, again check the material and check the concrete reinforcement, which we are going to design it as a beam in part 2 of the video. Okay, so that's done. Now add another one, add new property for circular cross section for the second floor column. So this is column B, right? And then the cross section is 0.8 meters. And check the material, check the concrete reinforcement, which we're going to design as a column, so that's fine. And then finally you have the first floor, right, rectangle actually, column A. Column A, it's actually a square, so it's 0.6 and 0.6 for both the width and depth. And check the material, check the reinforcement, right, column. Alright, done. Okay, so you now have beam A, B, and column A and B. Right, so then the next step would be you need to assign which one is beam A, which one is beam B, which one is column A and column B. So this is your actually beam B. So first of all, you move your cursor to that beam, and then you right click your mouse, and then you can see the section property here. Right, move your cursor here, double click your mouse, and then beam B. Select beam B. Okay, so done. And then the first floor beam, right click your mouse, sorry, and then section property, double click. This is your beam A. Okay, so select beam A. So done. Now what about the columns? So this one is column B. Do the same thing, right click your mouse. This is column B. Right, so just repeating column B. For the first floor, both sides, column A. So this is column A. Right, this one, the last one, the column on the right side, first floor, right click your mouse, double click. This is your column A. Okay. Now you can actually try to check whether you have input the things correctly. So you go to View, Set Display Options, and then click the General Options button. So the view type, instead of standard, we try to use the extrude. Okay, and then try to view the objects and don't show the reference line. Right, and see what you get. Right, so in front of you, this is, you can actually change it to 3D view. So on the top you can see this button here, click 3D, and you can use this button to rotate it. The reason that why we change it to 3D view is you can actually see that the rectangular cross section for the both beams. Okay, and then for the top two columns, you can see they are circular cross section. What about for the bottom two columns? If you zoom in, you can see that they are actually square. Let me just rotate to a better view. Right, you can see that the two bottom columns are square cross section. Right, and then the top two columns are circular. Right, so that's how you can actually check whether the data that you have input are correct or not. Now I'm going to change it back to XZ plane. Now I'm trying to use the window on the right to input the remaining things. So the next thing that we're going to use, change, is the bottom two supports. Actually on the paper it's given as fixed, so I'm going to select these two. Right, so just move your cursor there and then click your mouse. Right, so once you select these 2 points, go to Assign, Joint, Restraints. That means the supports. So change it to this Fixed Support button. Click this. OK. Right, so now you can see these two symbols represent fixed supports. Now the next step is to define the low cases, or first of all, they call it low patterns. So there are three low patterns: the dead low, the live low, and the wind low. So the dead low is already there. The next one is the live low, so give the live low a name, so I just call it LL. The type is live, and then you click this Add New Low Pattern. Right, and then the next one is a wind low, so I just call it WL. The type is wind. Okay, Add New Low Pattern. So now you have the three low patterns: dead, live, and wind. Now if you define to go to the low cases, so you can see the dead, live, and wind. And the second one, modal, is something that we don't need, so we can actually delete this locate. So on the right you just hit delete. Okay, so you have three low cases remain. And then the last thing about loading is to define the combinations. So if you go to load combinations, there are two combinations that we need to add. So add new combo, combination 1. Combination 1 is the dead load plus the live load with a scale factor or load factor. So the dead load factor is 1.4, and then plus live load 1.6. So change this number to 1.6 and then press add. So now the first combination 1 is 1.4 dead plus 1.6 live. Okay, then you add another one, com2, do the same thing, dead load 1.4, and then 1.4 dead load has to add to win 1.4 times the win load. Right, so combination 2 is 1.4 dead plus 1.4 win. Okay, so you got two load combinations. So the final thing before we analyze is to define the loading, right? So on the first floor, select the second floor. On the second floor, you select the second floor beam. You go to assign, which is go to frame load. It's a point load, right? So select this one, and then it belongs to live load. It's gravity going down, and the distance, the absolute distance from NI, that means from the left end, it's 3 meters. So you just type 3, and the magnitude of the loading is 250 as given. Okay. Now first floor, select the first floor beam, go to assign, frame load. This time it's a distributed load. It's live, right? It's a UDL. So go to the box on the right, uniform load. The magnitude of the uniform load is given as 40 kilonewton per meter. Okay, so it's done. Right, so if you want to display both live load on the first and second floor, you can go to display. So show this object load frame and click live. Right, so you can see your live load. Right, this is your live load case. Now we continue with the win. So the win, the first win load is applied at this point here, this joint here. So select this joint, go to assign, joint load, forces. It's win, so select win. It's in the horizontal direction, global X, right? That's X direction. And the magnitude is 160. Done. Go to this top left corner, select it, assign, joint load, forces, win, global X direction, but this time the loading is a bit smaller. It's only 80 kilonewton. Done. Now everything is done. You may ask, what about the dead load? The dead load, that means the self-weight of the material, self-weight of the frame. Basically, the program will calculate automatically for you, so you don't need to actually input the self-weight. So it's done. We're now ready to analyze. So go to analyze, set the analysis options. So this is a frame lying on the XZ plane. So select this button here. Click OK. Go to Analyze again. Set load cases to run. 3 load cases. Okay. So you just click Run now. So you need to save everything in one of the folder that you want. So I'm going to save it in a whatever. So give your problem or frame a name. So let's say this is called plane frame part 1. Right, so it's done, finished. So it only takes a few seconds. And then what you are seeing on the left side is the deformed shape or deflected shape under the dead load. You can actually see the deflected shape for other load cases. Go to display, show deformed shape. So if you want to look at the how the frame deflected under combination 1, let's say, right, that's how it looks like. And then you can do some funny things. You can do the animation of it. So on the bottom right, you can see the start animation button. You just push it. Right, so you can see the animation of how the beam, or how the frame actually deflects under the loading. And then you try to display the bending moment and shear force diagram. So I'm going to use the right window. So I click the right window and then I go to display, show forces, frames. So it depends on which load case you want to look at. Let's say I'm going to look at combination 1, shear force, shear 2, and then I want to show the values on the diagram. Click OK. Right, that's how the shear force diagrams look like. So if you want to look at the bending moment diagram, you do the same thing, show deformed shape. Let's say this time is combination 2. I want to look at the, we're trying to display the bending moment, so show forces. So combination 2, moment 3, show values. Right, that's how the bending moment diagram looks like. Okay, with values. Okay, and the final thing before we end this part 1 is I want to show you how to display everything in table form. So go to display, show tables. So what we need is the displacement or deflections, the reaction forces. In the frame output, we want to get the element forces. So click these few or select these few options, and then on the right side, make sure that you select the load cases that you want. So I'm going to just output combination 1 and 2. Okay. Right, so in front of you it's a table form. So this is the element forces you can see on the right side. And you can also select joint displacement, how the frame actually deflect in U1 is the X direction, U3 is the Z direction, R2s represent the rotation of the joint. You can also look at the reactions force at joint 1 and 4, the two bottom fixed support. F1 is the X reaction force, F3 is the vertical reaction force, F2 is the moment. And then the element forces, P is the axial force, V2 is shear, M3 is moment. And you can export everything to Excel, right? Because once you export everything to Excel, you can work on Excel and to input additional formulas. right? So this is how we export everything to Excel. This is the force and movement, displacement, and reactions. Okay, so that ends my first part of this video. In the second part, we will look at how to design the frame using the same software.